Alright girls, so we are on page 228 and we're doing lesson 4.1. At the top of this page you see that the parent function for an exponential growth is going to be f of x is equal to b to the x power. So remember that our f of x is the same thing as y. So we can go ahead and rewrite this as y is equal to b to the x. If you look at the example graph there, it shows that the main coordinate when graphing this parent function is going to be placed at 0, 1. And the reason that they get this point is that when you plug in a value into your chart, your xy chart, for x, if you plug in 0 for x, you're going to get y is equal to b to the 0 power. And if you remember from algebra 1, anything to the 0 power is just going to equal 1. So your point is going to go through 0, 1. Also, if you plug in the value of 1 for x, you're going to have y is equal to b to the first power. And anything to the first power is just itself. For example, if you have something like y is equal to 5 to the first, your answer is just y equals 5. So your y coordinate for the parent function will be b, and that will be placed somewhere over here. So the coordinate here will be 1, comma b. And since it's an exponential graph, you're going to be going up exponentially and then down. But it's never actually going to be hitting 0. It's just going to be getting super close. So let's go ahead and look at example number 1. Example number 1 gives us the equation y is equal to 2 to the x. Now with this, you can go ahead and make your chart. So you have your xy table, and we're going to plug in just some easy numbers. If we plug in -2, they plugged in -1, I'm just going to go ahead and plug in 0. I'm going to plug in 1, and I'm also going to plug in 2. So if you plug in 2, we're going to go back up to our original equation, and we're plugging in 2. So you have y is equal to 2 to the -2. Now remember, if you have that negative exponent, you're going to have something like y is equal to 1 over 2 squared, or y is equal to 1 over 4. So your y coordinate will be 1/4. If you're plugging in 0 into the equation, you're going to have something else. So you're going to have y is equal to 2 to the 0. And again, any exponent to the 0 power is just going to be 0, or 1, I'm sorry. So in this case, you have the coordinate 0, 1, because 2 to the 0 just equals 1. Next, we're going to plug in a positive 1 into our equation. So you have y is equal to 2 to the first power, which will be 2. Last number that we chose to plug in is 2. So you have y is equal to 2 squared, or 4. Now you have enough information for you to go ahead and start your graph. So make your coordinate plane and plot your points. So you have -2, 1/4, which will put you at somewhere along here. You have coordinate 0, 1, which we knew was going to go through. You have the coordinate 1, 2. You also knew it was going to go through that because that's going to be your 1, comma b back at our parent graph. Looking back at that, you have your 1, comma b over here. And that, for us, will be our 1, comma 2. Last coordinate that we are plotting is 2, 4. So right over here. And then connect your points. Notice that it's going up, and this graph will continue to get closer to 0 on the left-hand side. In looking at example number 2, you have the equation y is equal to 1/2 times 4 to the x power. Now this looks very similar to our parent graph function, however we do have this 1/2 out in front here. in making our chart, to go ahead and graph this, we're just going to do a typical XY chart and pick some values to plug in. So again, if you pick 0 for x, you need to plug it in and see what you get. So we're going to get y is equal to 1/2 times 4 to the 0. Anything to the 0 power is just 1. So you have y is equal to 1/2 times 1, or y is equal to 1/2. If we plug in a different value for x, let's say we go ahead and plug in the value of 1. You have y is equal to 1/2 times 4 to the first power, or y is equal to 1/2 times 4. Y equals 2. Having these 2 points, you can go ahead and create your graph, plot your points. So you're going to plot your points by first making your coordinate plane. Plot 0 and 1/2 right around here, and then 1, 2. Again, it's going up like this, and then curve down here, going towards 0. Example 2b is a little bit different. Your number that you have right in front of your 5/2 is a negative, so you have a negative 5/2 to the x. Again, make your chart so you have xy. Plug in 0, plug in 1. Plugging in 0, you get y is equal to negative 5/2 to the 0, or y is equal to negative 1. If you plug in 1 for x, you're going to get y is equal to negative 5/2 to the first power, or y is equal to just negative 5/2. After you have these 2 points, you can go ahead and graph them. Make sure you have your coordinate plane first. You have the coordinate 0, 1, and then 1, negative 5/2, somewhere down here. Connect your points, so notice that this is going down, like so. So if it's going down here, it never crosses that x-axis, so you're going to go ahead and have it go right up against the edge, approaching 0, just like this. Let's go ahead and look at example number 3, where you have something different. And I want you guys to recall looking at your parabolas and the basic parent graph for that. You know how you have your vertex of your HK. Exactly the same thing for exponential growth functions. Your parent graph will be the y is equal to AB h, or x minus h, and then again that k is tacked on at the end. So having this function, giving example number 3, you have y is equal to 4 times 2 to the x minus 1 minus 3. So your vertex will be that 1, 3. But it's something a little bit different with this. Typically in our parabolas, we're used to having our vertex be the 1, 3, and then just plotting that. However, for exponential growth functions, we're actually going to be going over 1 and then over 3. So we need to plot something first before we actually plot this original equation. What we're going to do is we're going to look at the y is equal to 4 times 2 to the x. Plot that one first, and then from there do some shifting. So let's go ahead and pick some coordinates to go ahead and plug in for this, and then we can graph it. Picking 0 and 1 for x because it's easy. If you plug in 0 for x, you get y is equal to 4 times 2 to the 0, or y is equal to 4 times 1, y equals 4. If you plug in 1, You get y is equal to 4 times 2 to the 1. Y is equal to 4 times 2. Y equals 8. Let's go ahead and plot this first, and then we'll do some shifting. So making your coordinate plane, you have 0, 4, and then 1, 8. Connecting these dots or points, you're going to get the graph looking something like this. Okay, so remember, that is only the graph of this equation right over here. We're not done yet. We need to graph the actual equation that they gave us. So looking at that vertex, and I'm sorry, I wrote it down wrong the first time. You have the vertex of 1, negative 3. Not 1, 3. So the 1 is being positive because in the original equation it's the minus h. So you're taking the positive 1. And we have that plus k here, so you're taking the actual value that they gave you for k. So in this case it's negative 3. So from our points we are going to go over a positive 1, and then we're going to be shifted down 3 on our graph. And that will be our new point. From our other point we're going to be shifted 1 and then down 3. So connecting our dots, we go up and we're going down 3. So look at how this is shifted up by 4, and then it starts hitting that 0. So this here point will go down 4 before it starts to plateau. So have it go down 4, 1, 2, 3, 4, and it will never hit that invisible asymptote. So it will never cross that line. And then that graph in yellow will be your final answer. If you're looking for some extra practice problems, go ahead and try number 3 in the guided practice. I'll write it down for you, and then I'll write down the answer. So try this problem here. You have f of x is equal to 3 to the x plus 1 plus 2. Give that a try really quick, put this on pause, and then I'll write down the answer for you in a second. Okay, so looking at this, we have our vertex that's going to be that negative 1, 2. And we're going to deal with that later. We're going to take our original equation, ignoring the vertex. So in this case, we just have our f of x is equal to 3 to the x. And we're going to plug in those simple values for x. So we're looking at 0 and 1. When you plug in 0 and 1, you're going to get 1 for y and then 3 for y. Plotting those, you're going to get something like the purple graph that we have on the left. Now in blue, I'm going to graph what our actual final answer will be. So remember, reference your vertex for this. Look at your point over here, 0, 1. We're going to go over negative 1 and up 2 to get to our actual point that we want. From the next point, we're also going to go over 1 and then up 2 to get our actual point that we want. And we're going to go straight down. So how far down do we go? Well, look at the parent graph that we drew, and notice how that parent graph, it starts at the coordinate 0, 1, and it goes down 1. So from our point, we're also going to go down only by 1. And it's never going to go anywhere lower than that. So our final graph will look something like that. Next thing we're going to look at is, turn the page, we're on page 230. We're going to talk about two different types of growth rates. So first one, on the top of page 230, you have the equation y is equal to a times the quantity 1 plus r to the t power. And you're going to use this when you have something increased by a fixed percent each year. So it's basically not going to change. On the top of page 231, the equation changes just a little bit. And this is A is equal to P times the quantity 1 plus R over N to the NT. You're going to use this equation when you have something that's compounded. This is for compounded interest. This is when it's happening multiple times a year. And that N stands for the number of times that is actually being done each year. Now we say year for time generally because for the most part we take it in terms of years. However, it could be considered in months. So T is basically whatever the given amount of time that you are told. So let's go ahead and look at this first equation, the top one up here, and do an example on that. Give me a favor and read through example number 4 for me. Take a second. So after reading through this, you notice that we're going to be looking at this the first equation that we're doing. And it's because it's not taken multiple times a year. It's just every year. So we're looking at just the simple one. That A there is going to be your initial starting point. And it says in the problem that you're starting off with the 2,573 computers. So you're going to have 2,573 plugged in for A. That 1 stays the same. For your variable, your R is going to be the rate at which you are increasing. And this one says that it's increasing by about 92% each year. So changing 92% into a decimal, you just get 0.92. And we're going to take it to the T power. Simplifying that just a little bit more, you're going to get 2,573 times 1.92 to the T power. That's all going to be equal to those number of incidents that occurred. So what do we plug in for T? Well, it asked us to figure out how many is going to happen during the next 7 years. So we're going to plug in 7 for T. You have N is equal to 2,573 times 1.92 to the 7th power. Plugging that all in your calculator, go ahead and do that. You're going to be getting around 247,485. And that will be your answer. Now let's do an example where we're doing that compound interest formula. So here you have your A is equal to your P times the quantity 1 plus R over N to the NT. Give me a favor and read through example number 5 for me. So in this case, P is going to be our principal amount, so it's basically the same thing as our A in the last equation that we did, so it's whatever you're starting off with. The A is going to be the amount that you actually have in your account after the time has gone by. So in reading through example 5, you figured out that you deposited an initial amount, or that principal amount, of $4,000 into your account. Part A says it wants it to be compounded quarterly. Quarterly means 4. So you're going to have that 1 plus R over 4, because N is the number of times that you're compounding it. So 4 in this case. You're actually only doing it for 1 year, so your time will be just 1. So your exponent will be 1 times N, or 1 times 4. And it gives you a rate of 2.92%. So changing that into decimal, you're going to get 0.0292. Sorry, you can't really read that. That's all going to be equal to your A, or your amount that you have in your account after. After you have all those all set in, it's just a calculator problem. Simplifying it just a little bit, you get A is equal to 4,000 times 1.92 0.0073 to the fourth. Your final answer is just going to be 1,118.09. Part B wants you to do it daily. So your n will switch from a value of 4 to a value of 365 because there are 365 days in the year. So your equation will be the same thing except for your n. So you have your original amount that you start off with, 4,000, times the quantity 1 plus your rate stays the same, 0.0292, over this time 365 to the 1 times 365. So in this case, you're going to get 4,000 times 1.00008 to the 365. That's going to be equal to the amount that you have in your account. So your final answer will be around 4,018.52. 4,118.52. Okay, and that is it for 4.1.